Hello and welcome to all students. In this lecture we study about the differentiation and we learn about the gradient of scalar valued function. Now in the previous lecture we studied about the gradient of scalar valued function, but in this lecture we study the last or next important point. That point is Euler's theorem. Okay, so let us start. So first of all we have the chain rule for scalar field. So what is that chain rule? We will see here. Suppose chain rule for differentiation. Okay, suppose z is equal to f of x comma y, means z is a function of two variables x and y, is a function of two variables x and y where each of x and y is function of variable t. Then so what is given to you here? We have given a one function f which is function of x and x and y they are again a function of variable t. Each of these x and y both are functions of variable t. Then if we find the derivative of z with respect to t, or how to find derivative of z with respect to t, that we will see here. And it is nothing but gradient of f of x comma y dot product with x dash comma y dash. Once again, so derivative of z with respect to t is equal to gradient of f of xt comma yt and dot product with vector x dash t comma y dash t. Here dashes are the nothing but the derivatives, first derivatives of the functions with respect to variable t. Okay, and it is equal to, so gradient is nothing but it is a vector with two components, dou f by dou x comma dou f by dou y, and dot product with x dash t is nothing but partial derivative of x with respect to t comma partial derivative of y with respect to t. Okay, and it is equal to, if I take a dot product we get a scalar quantity, sorry, it is a scalar quantity, dou f by dou x into dou x by dou t plus dou f by dou y into dou y by dou t. So if z is a function of xy and x and y are again functions of t, and if we want to find out derivative of z with respect to t, then that derivative is given by the formula dz by dt is equal to dou f by dou x into dou x by dou t plus dou y by dou y, sorry, dou f by dou y into dou y by dou t. So this is the formula. Okay, so keep in mind or remember this. So this is in the case of two variables. If we have case of three variables, then similarly if w is a function of three variables x comma y comma z, okay, here x, y and z are again functions of variable t. Okay, then by chain rule how to find derivative of w with respect to t is given here. So derivative of w with respect to t is equal to dou f by dou x into dou x by dou t plus dou f by dou y into dou y by dou t plus dou f by dou z into dou z by dou t. So this is a formula to find out derivative of w with respect to t when w is a function of xyz and xyz are again functions of t. Okay, so this is our chain rule in case of three variables. Okay, now we state here the theorem, Euler's theorem for functions of two variables. Okay, Euler's theorem for functions of function of two variables. So let us write the statement of this theorem. If f of x comma y be a homogeneous function of degree n in the two variables x, y possessing first order partial derivatives, then what we have, this identity x into dou f by dou x plus y into dou f by dou y is equal to n into f of x comma y. So once again, how to read this identity? X into dou f by dou x plus y into dou f by dou y is equal to n into f of x comma y. If here function f of x comma y, f is a function of two variables x and y, and that function is a homogeneous function of degree n. So we know that what is meant by homogeneous function. Okay, in the last year we saw what is meant by homogeneous function. So okay, so when we say that function f is homogeneous, f of x comma y is homogeneous, if f of xt comma yt is equal to t raised to n times f of x comma y, if function f satisfies this condition, then that function f is called as homogeneous function. Once again, function f of x comma y is said to be homogeneous function if it satisfies the condition f of xt comma yt is equal to t raised to n into f of x comma y. Okay, so here function if our function f is homogeneous with two variables and two variables x and y possesses partial derivatives, then x into dou f by dou x plus y into dou f by dou y is equal to n into f of x comma y. Okay, so we write the proof of this theorem. If f is a homogeneous function of degree n, then we have f of xt comma yt is equal to t raised to n into f of x comma y. So this is the condition of homogeneous, this is the condition on homogeneous function. Okay, our function is homogeneous if and only if this condition is satisfied. Now let u is equal to xt and v is equal to yt. Then in that condition, wherever is xt we put u and wherever is yt we put v. So f of u comma v is equal to t raised to n into f of x comma y. F of u comma v is equal to t raised to n into f of x comma y. Okay, so our equation will look like this. Now differentiating both sides with respect to x. So above equation we have, so this last equation we have to differentiate with respect to t. Okay, now see what do you get. On the left hand side we write derivative d by dt of f of u comma v is equal to, on the right hand side also we write the derivative of the right hand side function t dt of t raised to n into f of x comma y. As we are writing derivative, with respect to t. Therefore, on the left hand side, by using chain rule of derivative, we have on the left hand side we use chain rule. So here f is a function of uv and uv are functions of t. Then by definition of uh, then by the chain rule, left hand side will become like this: dou f by dou u into dou u by dou t plus dou f by dou v into dou v by dou t is equal to, on the right hand side we write the derivative of t raised to n as n into t raised to the power n minus 1 and function f of x comma y as it is, because f of x comma y is a constant with respect to the variable t. Okay, so dou f by dou u. So on the next step we write dou f by dou u and the derivative of dou u by dou t is x plus dou f by dou v and derivative of v with respect to t is y. It is equal to n into t raised to n minus 1 into f of x comma y. Now on the next step we put t equal to 1. If I put t equal to 1, then dou f by dou u will become dou f by dou x, because u is equal to xt and t is 1, so u becomes x. So dou f by dou u is equal to dou f by dou x and dou f by dou v is equal to dou f by dou y. So equation star becomes, and that equation star will look like this: x into dou f by, so equation star becomes like this: x into dou f by dou x plus y into dou f by dou y is equal to n into f of x comma y. X into dou, once again, so this is the Euler's equation. Okay, in case of two dimension, or Euler's equation for two variables x and y: x into dou f by dou x plus y into dou f by dou y is equal to n into f of x comma y. Now we write the Euler's theorem for function of three variables. Okay, if f of x comma y be a homogeneous function of degree n in the three variables x, y, z possessing first order partial derivatives, then x into dou f by dou x plus y into dou f by dou y plus z into dou f by dou z is equal to n into f of x comma y comma z. The proof of this theorem is similar to the proof of the previous theorem. These two theorems, so this theorem is the extension of first theorem. Since f is a homogeneous function of degree n, therefore it will satisfy this condition: f of xt comma yt comma zt is equal to t raised to n into f of x comma y comma z. Let u is equal to xt, v equal to yt and w equal to zt. Then our above condition will look like this: f of u comma v comma w equal to t raised to n into f of x comma y comma z. So differentiate this equation with respect to t and we get the step. So derivative of left hand side with respect to t is equal to derivative of right hand side with respect to t. So for the left hand side we use our chain rule for differentiation, because f is a function of uvw and uvw are functions of t. Therefore derivative is dou f by dou u into dou u by dou t plus dou f by dou v into dou v by dou t plus dou f by dou w into dou w by dou t equal to n into t raised to the power n minus 1 f of x comma y comma z. So dou f by dou u into x. So that x is nothing but derivative of u with respect to t, because u is xt and derivative of xt with respect to t is x. So plus dou f by dou v into y plus dou f by dou w into z is equal to n into t raised to the power n minus 1 into f of x comma y comma z. Now for t is equal to 1, dou f by dou u is equal to, it becomes dou f by dou u becomes dou f by dou x, dou f by dou v becomes dou f by dou y, and dou f by dou w, it becomes dou f by dou z. And thus equation star becomes x into dou f by dou x plus y into dou f by dou y plus z into dou f by dou z is equal to n into f of x comma y comma z. So this is our Euler's theorem in case of three variables. If our function f is homogeneous function of three variables x, y, z, and it is a homogeneous function of degree n, then our Euler's theorem is x into dou f by dou x plus y into dou f by dou y plus z into dou f by dou z is equal to n into f of x comma y comma z. So in this way we completed these two theorems, and for any queries you can contact, and we stop our lecture here. Thank you very much.